Hi there, in this video we're going to be talking about categorical data, the different types, and once we've done that we'll then go on in the next videos to start playing with some data. So let's jump in. Okay, categorical data. There are actually two types of categorical data, ordinal and nominal, and I'll go through what these are, but I've put a third type on here, dichotomous, or also known as binary data. Strictly speaking, it's not a separate type of data, but in statistics we often try, in many ways, to try and make our data binary, because there are some specialized statistics that are much more powerful that we can use. So I include it here for the sense of completeness, and just so that you know that dichotomous is a particular type of data that we can use to our advantage, and I'll come on to what that is in a little while. Right, one thing that is really important when we're talking about categorical data is that the categories must be mutually exclusive. In other words, when you select a category that describes a particular thing that you're looking at, the description of that can only fall into one category. So if you've got possibilities of small, medium and large, it can only be small or medium or large. It can't fall into both small and medium at the same time. If you're describing things in different ways, in which one particular dimension is small, and in a different dimension it's large, for instance the height of something and the width of something, it can be small in one sense and large in the other. That's okay, but that's two separate columns of data. Categories must be mutually exclusive. They cannot fit in more than one category at the same time, and that's really important. If your categories are not mutually exclusive, then it becomes difficult in trying to analyze these data. There are ways in which we can do it, and there is a particular type of data that we'll come across later where categories are not mutually exclusive, and I'm going to show you how we deal with those later. But strictly speaking, categorical data, the categories must be mutually exclusive. Okay, I'm going to go through the different types of data now. So ordinal data, what we have here is categories that are ordered. There is a certain flow to the categories, and these categories can either be named or numbered. If they're named, you might have names such as small, medium or large. Usually the names of these categories give you a sense of order, but they don't have to. There can be something else that doesn't give you a sense of order, even though they are. The names actually don't matter. They're not important. All that's important is that you understand that the categories are ordered, and these are ordinal data. Alternatively, when you number them, it's typical to start 1, 2 and 3 and so on, but they don't have to be. They can start with any number, and again the numbers are usually consecutive. They don't have to be, but it makes a lot of sense when they are. The categories themselves do not have equal distance between them. Whether they are numbered or not, it doesn't matter. So the distance from 1 to 2 is not equal to the distance from 2 to 3. So if you've got categories of small, medium and large, the distance from small to medium is not the same as from medium to large, because you haven't defined what small, medium and large are. They may be, if these are t-shirt sizes, they might be different in the width, in the height, in the chest size, in the shoulder size. There are multiple reasons as to why you cannot give a single measurement, and this is why they're ordinal data and they're not measured in terms of a number 1.23 or something like that. They are ordered categories that do not have equal distance between the categories, even if they're numbered. Here are some examples of some ordinal data. We might look at socio-economic status. So if you might see on a survey, what socio-economic class do you belong to? And the options might be lower class, middle class or upper class, and you can tell there's a clear progression in the classes. Opinion, agree, mostly agree, neutral, and so on. I'm sure you've seen all of these before. Tumour grade, these ones are numbered 1, 2 and 3, but they don't have to be numbered. They can be something else. Political orientation, left, middle, right, time of day, morning, noon, night. All of these have got a progression, and you cannot. There is no the measurement difference between each of the categories is not the same. Excuse me. When it comes to nominal data, these categories are named. That's where the word nominal comes from. The categories are named and they are unordered. So the categories themselves, they could be either named or numbered, and that's okay. If they're named, an example of this might be red, green and blue. There's no order to these, and if you can number them 1, 2 and 3, just because you number them 1, 2 and 3, that doesn't mean that they suddenly have order. You cannot call them ordinal data just because you've put ordered numbers on them. All this means is that you've put some numbers on them. They're just tags, they're labels, but the categories themselves are still unordered. And some examples of this might be nationality. You choose what nationality do you belong to? British, American, Spanish, or whatever. Okay, there's no order in these. Genre, rock, hip hop, jazz, classical. Which is your favourite? What is your hair colour? What is your favourite animal? Which is your favourite pizza topping? All of these are nominal data. There is no order to them, and you can just simply choose any one of them. And finally, we're getting into dichotomous data. As I said, these are binary data. There are two categories, and it doesn't really matter whether they are ordinal or nominal. Ordinal, as we know, have order, and nominal don't have order in the categories. But it doesn't matter. We treat them the same anyway. In statistics, when we use our statistical tests, there are two categories, and it doesn't matter if they're in what you might consider to be the right order or the wrong order. The statistical tests are still valid. So, and as I said earlier, there are some statistical tests that are really powerful for dichotomous data, much more powerful than when you've got 3 or more categories. And so we quite often try to consolidate data into 2 categories so that we can use these more powerful statistics. And I'll come into that a bit later, and I'll show how exactly we get dichotomous data if we have more than 2 categories. Okay, coming up next, we're going to have a play with some ordinal data, and then we'll see what we can learn from that.